Hi, everybody. My name is Igor. This is Misko with me. We come from Google, from California, and we are two of the guys that started AngularJS a few years ago. And we came to you today to talk about the future of AngularJS. Now that Angular 1.2 is released, we are starting to look into the future. What is it that we want to do with Angular, and what are the improvements that we'd like to bring to you? But before we do that, let's look at some of the goals that we're trying to achieve with Angular.
Do you have like a crystal ball that you can look in the future?
I don't have a crystal ball.
You don't, okay. Next slide. Oh, so first I want to tell you guys how much we love you. I mean, you guys were an awesome people that were made all of this thing happen. You submit awesome pull requests, run the community mailing list, and so on. So we just love you guys. And one of the things is we think that through all the work you guys can do and with technologies such as Angular, it's actually possible to change the world and make it a better place. I think technology allows us to build apps, and by making apps easier to build, we can start building apps that were simply not cost-effective to build before. And I think that's one of the game-changing things about technology.
It happened to me so many times that when I talk to you guys, you just come to me and tell me, hey, I was able to build this app that it was not possible to build before just because it was so difficult to do and I didn't have time. But now with Angular, I feel much more productive, and I was able to do it in one weekend or in 1 week. And it just feels good to see that these apps now exist that didn't have existed before. We have a little disclaimer here, just so that we don't get burned by what we say. Everything we're going to say is highly speculative. It may or may not happen. We don't know yet. We're going to try our best. And what we came here to talk to you about is like just share the thinking and the ideas we have. The finished product will probably look very different from what we're going to show you on slides today. And it will be built far, far in the future, here or maybe in the galaxy far, far away.
So what are we going to talk about? I really would like to talk about some browsers, some standards that are coming to the browsers and how exciting it's becoming, community and how we would like to make it even more awesome, a couple of crazy, insane ideas that we have.
Browsers are this thing that we use every day. Everything that we write executes in browsers. Our applications are deployed through browsers. And we rely heavily on browsers to get our stuff done. Up until now, Angular used to support browsers like IE8. And this was okay, but we felt really constrained. And we feel like in order for us to be able to push the envelope further, we need to drop the support for all browsers. So in the future, what Angular is going to focus on is the modern browsers. These are evergreen browsers, which means browsers that will self-update without the user having to do or take any action. This is awesome because it will avoid the situation like we had in the past where some users were stuck on IE6 forever and couldn't upgrade because they didn't know how to do it or it was just too complicated. So with evergreen browsers, the rate of improvements in browser technology will increase, and we will be able to take advantage of new APIs much sooner than it was possible before. Browsers are developed around standards, and they are evolved through standards. And there are some really, really interesting standards that are coming to browsers and that's already available today. And we would like to take advantage of these. The most interesting one for us is web components. This is a standard that allows you to build reusable components. And Misko's going to tell us what these standards really are and what are the standards that I want to take advantage of.
Yeah, so Web Components is this umbrella standard. It is a meta standard because it collects a whole bunch of other standards that come together. One of the most common one that people know about is Shadow DOM. And a Shadow DOM allows you to encapsulate DOM just like you can encapsulate code into reusable components. But Shadow DOM by itself is not reusable. It really just deals with how DOM can go through encapsulation. To make it reusable, you need something like document register, which allows you to actually make up new custom elements. In essence, you can make up your own language in HTML. So you can have tabs and my button, my fancy buttons, and so on. So we would like to take advantage of that because that gives others to be able to use it as well. The next thing you need in order to have reusable components is template. And what template is an inert piece of DOM. And the word inert is important because there's many hacks inside of Angular that we placed in order to make code inert. The most famous one is the ng source that you have to place on image instead of just regular source. And finally, to make things really reusable, you need to be able to scope CSS so that one CSS selector doesn't leak all over your applications. And so together, these standards really make it so that components become really usable. And we would like to take advantage of all these things.
So one thing that these new standards allow us to do is to consolidate the terminology and take advantage of some of the new things that were not possible before. A good example of consolidating on a terminology is transclusion. Transclusion is something that we came up with for Angular because we needed a way of taking a content of an element and projecting this template through a hole in a template of another component. This was standardized using web standards as an element called content, and the whole process is called node distribution through insertion points, which sounds not that much easier than transclusion, but
I like transclusion better.
but we'll have this standard terminology that different libraries will share, and we'll know what we talk about. Another thing that I really like about web components is that web components allow you to build elements. They are not really, some people say that they're custom elements, but they're really just elements from the view of other libraries and frameworks. What this means is that if you build a component with a different library or framework than Angular, Angular can use this component and see it just as element and can use it. And the vice versa is also true. If you build a component with Angular, you will be able to export it as a web component so that other libraries can take advantage of it.
So the next thing is Object.observe. Object.observe is actually a standard that was heavily influenced by Angular when it was being written. And it allows you to notice object property mutations or observe the object changes. And this can be done without the need of getters or setters or proxies. And this is very important because oftentimes third-party libraries will hand you objects these objects will be further modified behind the scenes. And that means things like getters and setters and proxies don't work. And so it's really important that we're actually able to observe the fundamental object at its core. And currently we do this through dirty checking, but Object.observe can do this for us. And the nice thing with Object.observe is that we no longer have to have this linear degradation in speed as more and more watches gets created in the system. The other interesting property of Object.observe is that it's asynchronous. And this is very important because it means that two things. First of all, we have coalescence of property changes. So if the property gets changed over and over again, like for example, a length property on an array as you're inserting items into it, you don't need to be notified of every single one and update the DOM every single time. And the other thing that it allows you to do is that it provides a consistent view of the world. So if you have a function that needs to change multiple properties, by being asynchronous, you can wait until all the properties are changed before you can look at it and you can see a consistent view of the world. And it really means that Angular does not have to do dirty checking.
The next standard that we are looking at, this is one of those that are already implemented in several browsers, is DOM mutation observers. DOM mutation observers allow us to be notified of structural changes to the DOM. So let's say in existing Angular application, you're writing a widget, and this widget uses some third-party library that does DOM manipulation. Right now, when this third-party library does DOM manipulation, you don't know about it most of the time, and Angular doesn't know about it never. And this can cause problems because now you have like two libraries or two frameworks modifying the same DOM at the same time, and bad things can happen. DOM mutation observers allow us to get notified of these changes and take actions to take these DOM changes into account so that we can accommodate these changes that happen through third-party libraries. This also means that the whole Angular compiler will need to change, but this is implementation detail that we'll need to sort out.
So the nice thing is that many of these things exist as polyfills. Now, most of these standards are actually not even finished, and so there are actually polyfills for this future. We call them polyfills, or probably a fill, which is an implementation that will probably be standardized in the future. And so our good friends at Polymer project have already implemented many of these, and we can take advantage of them. And the idea is that we can polyfill older browsers that don't yet support these APIs, and we can start building the Angular on top of these new standards. Which browsers we'll be able to support really is going to depend on which browsers these polyfills are capable of running on.
So some of the examples of how we can use this is polyfills. Right now, when you're building a component with Angular, you do this through the Directive API, and the Directive API allows you to define a template. Now, this template currently is just a chunk of DOM that is attached to the element that you put the directive on. But in the future, with Shadow DOM, we can actually totally encapsulate this template of the element by using Shadow DOM. And from the perspective of the explorer of the DOM, this template of the custom element will be completely hidden. Another example we already mentioned is Object.observe. With Object.observe and Polyfill for Object.observe, we can get rid of the $apply and need to call $apply if you're dealing with third-party libraries that are synchronous. And the last one is the Mutation Observers, which will completely redefine how the compiler works. Community is a big part of Angular, and you guys really help us shape what Angular is. And we see that the way we build Angular today is not really the best and the most scalable solution. Right now, Angular brings a lot of innovative features. It has directives, has dependency injection system, it has this awesome data binding. The expression evaluator is quite unique. And we also added new things just recently, like error message minification through Miner. But all of these features are really available to you only if you use Angular as the whole. It's all or nothing proposition. It would be really nice if you could take advantage of only pieces that you actually need for your project. And this is something that we plan to do by breaking up the whole framework into smaller pieces. This will be libraries that are focused on taking care of one particular task, and you can then decide which pieces you need. The Angular project will then become an umbrella project for all these libraries and smaller projects, and will coordinate and make sure that all these libraries will work together really well and create a cohesive whole. The whole community will benefit in many different ways. One of them is that the community can build better Angular, either by picking the components that you really need for your application, or by replacing components in Angular. We've seen this in the past with our router. Our router was designed 4 years ago when things were quite different. But today, there is a project called UI Router, which brings many new innovative features and has become, for many, the de facto standard for routing in Angular applications. And we would like to see this kind of innovation happening outside of the core of Angular more often. And by breaking up the project into smaller libraries, we hope that we will encourage this kind of innovation to be happening. The last thing that I would like to mention is that by breaking up Angular into these smaller libraries, we will make it possible to use the components that currently create Angular and make them useful in contexts where the whole Angular doesn't make sense. For example, our dependency injection system is quite awesome and many people like it, but it's really hard to use it in a Node.js application. But by extracting it and making it its own project, you will be able to take advantage of it in Node.js, and if you need to make customization, it's going to be much easier to do and create this derivative work. We have some crazy ideas that we would like to share with you.
I love crazy ideas. It's what I live for.
One of them is asynchronous DI. Misko, what is this asynchronous?
Yes, asynchronous DI. So everybody knows what dependency injection is, hopefully. And asynchronous DI just takes it a step further, because what if we could inject not only instances of objects, but also lazily load both data and code? And so in order to do lazy loading, we have to get in the world of asynchronous dependency injection. Now, before we talk about dependency injection and asynchronous dependency injection, we really have to talk about DI versus AMD and friends. So AMD is really a synchronous module definition, and I don't mean specifically just AMD project, but also all of the other lazy loading libraries that are out there and all the other systems that deal with module loading. But what AMD and friends really are interested in is in what order do we load code. And typically most of the code loading happens at the beginning of the application. As the application runs, less and less code loading happens. Some applications still load things asynchronously as they run, but for the most part, applications really load all of their code at the very beginning. Now, DI is very different, because DI is not interested in which order do I load code. Instead, DI is interested in which order do we instantiate the code that was loaded by the AMD. And unlike AMD that runs primarily at the beginning, DI is something that runs continuously in your system. As you're navigating between different pages, things are getting instantiated and thrown away and instantiated again. So DI and AMD are a little different things, but they share a common vocabulary that kind of hints at the fact that there is some overlap between them. And if we could merge the two pieces together, if we can make a dependency injection system that knows how to deal with not just with code, with data, but also with code and understands modules at the kind of a raw level, I think we could build a system where by simply asking for an object that has a dependency on code that is not yet loaded, the asynchronous DI can be smart enough and say, oh, I see that I need to instantiate a dependency that has not been loaded yet, and I can then fetch it, load it, and then instantiate the object. So what would it look like? Let's look at some example. This is an example that's a little contrived, but I'd like to point out 3 different kinds of dependencies that really exist. There is the actual dependency, which you can resolve instantaneously. In this case, it's the size property, which simply is 5. So in the DI system, you can just ask for size, and you would immediately get 5. But there are different kind of properties that we cannot resolve immediately. So for example, users is a list of users that has to be loaded from the server. And that means that, at best, our factory can return a promise for XHR. In other words, it is a promise that eventually will resolve into the set of users. Now, you can inject that today into an application, but what you're really injecting is a promise, which means that inside of your application, you have to say things like users.then. So you have to write a then block. And this is tricky because inside of your tests, instead of having a simple unit test that says make an app, pass in a list of users, you now have to have a more complicated test which has to mock out the whole interaction with the server, has to have a flush HTTP backend, all the things that we have hopefully put it into Angular to make testing easier, but it's still non-trivial. And finally, there is the idea of loading additional code. Now, if you think about it, there is not much difference between code and data inside of JavaScript. So what if we could simply say, I want a storage. In this case, notice it's a capital S, which means it's a type. And you can load it in XHR, using the XHR, you can load the data lazily. But then the system returns a promise of the code. Now, again, the same problem exists. In order to use the storage, you have to write a then block. But if the asynchronous DI understands the concept of promises, what we can do is we can simply delay the instantiation of the app until all of the individual promises are resolved. In other words, it's the DI system that writes the then blocks rather than yourself. And then your application code can simply be synchronous. So your application simply says size, users, and storage. And the users and storage are already resolved, so you can simply do your operations. And this greatly helps with unit testing and also with just a cognitive load of understanding what's happening in a system.
It's good to encapsulate all this asynchronous into layers and then just deal with them in a single layer and then just have the rest of the application run synchronously.
Yes.
Another project that we are thinking of, and this is something that we actually have a first-hand experience through Angular Dart that Brad mentioned earlier, is zones. Zones is a way of attaching context to callbacks and propagating it as the callbacks go through multiple event turns. The goal of zones is to remove the need for $apply. You know that we mentioned Object.observe and how it can help. But the polyfill for Object.observe still relies on dirt checking, and you need to explicitly say, hey, go do dirt checking. Zones can actually help with this because they can wrap callbacks and do this apply or trigger dirt checking automatically so that you don't have to. It also makes some of the things that were not possible before possible. Good example of that is long stack traces. Long stack traces, if you ever debugged a synchronous application, you know that if you get a stack trace, this stack trace contains information only about the current turn of the event loop. So you don't know where the callback was registered or what happened before this callback was even registered. With long stack traces, we're able to capture the history. Let's say I registered event listener for this button, and a user clicked on it, that triggered an XHR, and the XHR came back from the server, and then in the response to the XHR, an error happened. The long stack trace can tell you the whole history, how this error happened, and what happened before the actual error happened.
So let's look at an example. Suppose we have a standard promise library that we've gotten that is not Angular aware. Now, the reason we actually bundle a promise library inside of Angular is because we made it Angular aware. But let's say we want to use an existing one. If you want to do an existing one, the line one is really how the world would work, where you say xhr.get, you do some URL, and then you have the then block. But in order for the then block to work, you have to wrap it in apply, right? This is the reason why the one that we bundle with already does this for you. But this apply is important because it's what enables data binding. And without it, it simply doesn't work. But so how could we look at it in the context of a zone? So with a zone, what would be possible is to simply instantiate Angular zone. And what the Angular zone says is basically that whenever a VM is finished with its turn, please run the dirty checking. So if you have the polyfill, you would run the dirty checking polyfill. Otherwise, you talk to Object.observe to fetch the data from there. And by instantiating the zone, you can then inside of the zone create what we call a run block. And in this run block, you can say promise xhr get. Now, what's unique about this is that the zone can intercept when the xhr is installing the callback for itself. And it can intercept and wrap and delegate that callback through a wrapper that on the end of it would allow us to run additional operations, such as checking what the stack traces are, doing dirty checking, and so on.
And should there be another asynchronous event in response to the response from the server coming back, that will also be wrapped, so this propagates further.
Correct. So zones, if you think about them, are kind of a thread local variable. But there's no threads in JavaScript, right? So we have these things called callbacks. So they're kind of a callback chain local variable. So once you start off a process with a zone, the process continues in the same zone. And so an important thing would be, from the previous slide, would be that if you, for example, start an XHR outside of the Angular zone, then the then portion of that of the promise does not get resolved within Angular context. Therefore, you can have applications that are mixture, the old system together with the new system, and they can coexist because simply by defining where the application kicks off and because these zones propagate, they will correctly behave throughout. Now, how do we achieve this? We achieve this by, well, monkey patching all of the asynchronous API in a browser. So there's a gentleman down here, Brian, who's actually working on this already. He's trying to figure out every single API in a browser that's asynchronous. If we can monkey patch it and run it through the zone, we basically have a hook in figuring out where all of the turns happen. We can then wrap all the asynchronous APIs into a piece of delegating code that wraps and propagates the zones so the zones are consistent. And because we can do this once, we can basically share this with the community, and other projects can be written on this particular thing. And the most important part of this thing is that we can detect VM turns. And this is the thing that's needed to make Object.observe polyfill possible.
So one thing I like about zones the most is that they're composable. You can create multiple zones and just nest them as you need them. We have a few examples on the slide. There's always going to be a default zone, which is going to behave just like the regular browser. It's not going to add any extra features to it. But then you can install on top of it a stack trace zone. This is the zone that will make the long stack traces possible. And you can enable it only in the development mode, so that there is no performance penalty in production, or you can enable it whenever you need to, actually. Then, on top of that, you can install the Angular zone, which will help with the data binding and the polyfills that need to know when the turn of the event loop changes. And what I'm excited about is that you can also have mock zones. These are zones that will allow you to easily mock out some of the global APIs or global state in the browser, and APIs that are really hard to test, like set timeout and set interval. And they will allow you to write synchronous tests that will, from the perspective of the test, from the code under test, look asynchronous. So your test will be completely synchronous, but the code that you're testing will think that it's asynchronous. And this dramatically simplifies the whole testing process. So we talked about web components, some of the APIs that are coming in the browser. We talked about zone and how we would like to solve some of the issues that have not been solved before. But there is another tectonic shift coming into the browser world, which is ECMAScript 6. ECMAScript 6 is a standard that defines what the JavaScript in the browser looks like and how it behaves. And this is a specification that is that has been finalized. It's taking longer than what everybody would like, but we already see some of the nice outcomes of this specification being implemented. Two features that we are really excited about are classes and modules. Classes will allow us to have sane syntax for creating classes and types for JavaScript without all the prototypical boilerplate code that you have to write today. And modules, I think this is one of the most important things for the web, because modularization is definitely the way to go. And if you're a Java developer, you know how important module systems are. Dart has a module system built in. We need one for JavaScript as well, and I can't wait to get my hands on the module system in JavaScript. These two features will make DI even better, and we'll see that shortly, especially if we extend ES6. But in order for us to be able to use ECMAScript 6, or this new JavaScript, we need a way to run it in today's browsers. And this is what a project called Tracer Compiler from our friends at Google does. It takes a code that is written in this future syntax and compiles it into ES5 compliant code, which runs in today's browsers. So this allows you to write code in something that doesn't exist yet, but run it in the browsers. And this is something that we want to use. And Misko's going to talk about how we're going to extend the Tracer compiler in the future.
So one of the things we actually learned from Angular Dart is just how nice it can be to use classes for things like directives. I'm sure for those of you guys who know AngularJS directives and the directive definition object, it's a little hairy. It's a little complicated. And so we wanted to really focus on really cleaning up the API. And this is what we were thinking of, having a simple class that says ngBind directive. It has a constructor and says, well, I need an element. This is the element on which I was declared at. And there might be a method on it, for example, setText, that takes the value of the expression that was at that attribute and then simply updates the DOM. But where does all the information come from? How do you know that this is a directive, and how do we know what to pass into the constructor, and how do we know how to call the particular method? So annotations would really help in this particular thing. ES6 out of the box does not have annotations, but there's already talk about what would annotations or decorator look like in the context of ES6. So this is one example that we're playing with, and we actually already have a version of Tracer compiler that understands this, and we're kind of just playing with them to see what the best syntax is available. Now, in this particular case, the ngDirective attribute annotation tells the system, hey, this class is really a directive. When should I use it? Well, you should use it when this CSS selector triggers. And in this case, it's a square bracket, which means it's an attribute, and it's ngBind, which means if you come across an attribute called ngBind, please trigger this directive. What does it mean to trigger? Well, just instantiate it. That's fine. So I call the constructor, but how do I know what to inject into the constructor? Well, you can have an annotation that simply specifies what all the parameters that you want to inject in the system are. And finally, what I think is the best part of the system is that we can also annotate methods, and we can say, please call this method whenever the ngBind will have an expression. Whenever the expression evaluates to a different value, please call this method automatically. And what this allows us to do is to completely take the whole watching out of the directive declaration, right? So no longer watches and scopes are present in here. Really, you can focus on what the directive is meant to do. Now, but what would be even better is if we can actually move the add inject annotation into type system. Now, types, there's no types inside of, well, there's types, but there's no classes and assertions inside of it. Well, there is TypeScript that's kind of forging the way in this particular direction. And it turns out types can be useful. The thing with types is that they're not free. They do have a cost. And so the question is, for this particular use case, are the types paying their rent, or are they costing more? And this is really something that the developer should be able to decide on a case-by-case basis, rather than language saying you will have types everywhere, which is the extreme of Java, or the other extreme of something like JavaScript, where there really aren't any types and everything is dynamic. But before we talk about all these cool things, I really want to point out something very, very important, and that is that we don't want to make ECMAScript 5 a second-class citizen. We really want to make sure that when you implement a directive in ECMAScript 5, when you want to use this new version of Angular, you're not going to be automatically forced to also add a compiler step to your process. And so everything that we generate, we want to generate in a way that is easy to do in natural ECMAScript 5. So this is an example of what it might look like. You create a type inside of ECMAScript file, just like you do it today, which is a constructor function. And then you simply annotate it using the annotation property. You simply monkey patch that function with annotation property, and you put all of the information on it. So whether you're using the nice, pretty syntax that ES6 will provide, or you're simply going back to essentially what we have today with JavaScript, you're not going to be considered a second-class citizen. This is, to me, this is dear in heart, that it should be important to mix and match projects. And this is also important because there's a huge ecosystem of existing JavaScript libraries out there written in ES5, and we want to make sure that you can mix and match. Like, this should not be a rewrite everything kind of a game. It should really be, you know, we love everybody. We want to just make everybody happy.
What I like about annotations is the toolability and how it enables toolability. Right now, when you look at many of the JavaScript, a lot of the JavaScript code, including the Angular code, it's kind of hard to create tooling around it, just because there is so much that happens during the runtime, and it's kind of hard to infer from just looking at the code. But annotations are this declarative way of describing the code and what it does and how it glues together. And this enables toolability. This makes the IDE support better, and also allows better post-processing or the build step in preparation for deployment.
So let's go back to these types idea. So types are interesting, but static types have this property that they really spread like cancer. And what I mean by that is, if you have a function that says, I need to take a string, the only way for the compiler to verify that it is indeed a string is to trace it to where the method, where the particular parameter was declared. And so it goes back and looks for the declaration, and if the declaration says something like x equals call this other function, well, then it has to recurse into that other function and then verify that that function indeed is returning a string. And this has to be done over and over again. And so it has this property that it really spreads like cancer. To really take a benefit of type system in a static world, you really have to type everything. And this is not very optional. And this especially doesn't help with third-party libraries. So if you have something like jQuery, the only thing you can really do is create an externs file for the compiler, so the compiler is happy. But if you think about what an externs file really is, it's just a one fancy cast, right? You're simply saying, pretend that what I say is true. Over here, like, don't go any further. Now, that's essentially what the externs file is. But we would really like to verify that it is indeed the case. So now there's different type systems out there. And so there's static type systems. An example of that is TypeScript. TypeScript is also not only static, it's also structural. Structural means that a triangle is a shape because it has a draw method. So it's simply by, if it looks like a duck, it is a duck. There's also an optional type systems, like an example of that would be Dart. But Dart is not structural, it is nominal, which means that you are a triangle is a shape because it inherits from shape. It is not a shape if it doesn't inherit. It's not sufficient for you to have the draw method. You actually have to have an inheritance present over there. Now there's other systems like, for example, type inference systems. But the type inference system is really just a static type system with a lot less typing. It doesn't have to be static. It could be also optional, like Dart. Dart has a type inference, but it's not as static as TypeScript. So those are the kind of things we have. But there's a special case, which is the JSON from third-party libraries and also JSON from the server. When the server returns a JSON to you, it would be really nice if you could actually assert and say, this is of the correct structural type. And this is not possible to simply do at static compilation time. This can only be done at runtime. So the idea of contracts is, or these dynamic types, or I'm just going to call them contracts from now on so that I don't confuse them with the classical sense of what types are for people. The idea of these contracts is really to just have a glorified assert statement. So if I say that something is a string, the compiler doesn't have to go and figure out and go into jQuery and verify that jQuery actually returns a string. Is that when I say I have a string, I simply put an assert statement inside of my code that says it is indeed a string. Now the nice thing about having this as a compiler-generated code is that you can turn it off in production. Right? This is only something that's available in there for you for tests and for development mode. It is not present in production. And contracts are functions. They're not a type of. So it's not like something is a shape because it inherits from shape. Rather, a contract is a function and can do a lot of interesting things. For example, we can say B is a string. Well, that's easy, right? You just say type of foo, it's a string. But we can do more interesting things. We can say C is a jQuery. Well, what does that mean? Well, an object is a jQuery object if it has the length property, which is a number, and it has properties that are enumerated by numbers, and all of them are of type a node. And if an object qualifies in these particular ways, then we can say, well, that's a jQuery object. And there is things we know we can do with jQuery objects. We know we can iterate over them. We know that we'll receive elements out of them, and so on. But you can do something even more interesting, which is you can say this string is not just any string. It's a CSS selector. So you can run a function over it that runs a regex that verifies that, yes, indeed, this particular string is a form that looks like a CSS selector. And these functions can be composable. These contracts can be composable. So that you can say things like it's an array of CSS selectors, in which case we'll actually go and verify that indeed it is an array, and indeed it has proper items that are strings that follow the regex that the CSS selector declares. So you can see that this is a very different kind of type system, and with this you can really have optional typing. So how would this be used in production? Or rather, how would you use this? You could declare classes, as you can see. You can optionally provide types, like children is jQuery. The constructors could have elements, and those type systems could be then used for dependency injection, for resolving what exactly my controller is. And when the code runs, and for example, in this case, there is an assignment, we can immediately verify that that method did indeed return a jQuery-like object.
Additionally, these types can also serve as a form of documentation, and they can also help as an aid to tooling and IDEs to help you navigate through the code.
But I really want to stress that they're truly optional. Adding or removing in no way affects anything else.
So to summarize? To
summarize, so contracts are really just a glorified assert statements. There's really no cost in production. They are verified in development mode and during runtime, but really just in development, which means test and development mode, and in production we simply remove them. They are composable functions, so they can really build up more or complicated assert statements about the way the system is. And this is really important, as I said, with JSON coming from the server. So if you can have data, if you can verify that the server actually returned the data structure you're expecting, because usually the server code really is a different team, right? Like it's usually Java or something else. And it's a different team of people than working on a client side. And so this kind of assertion at runtime that the server is actually returning what it is supposed to return is very useful and helpful. So we are really, this is not ES6 out of the box. This is slightly extended ES6 out of the, but we are kind of hoping that we can inspire the community and the standards body into incorporating these things in there. As I said, these things are already, the standards bodies are already working on it. There's TypeScript is already an example of having type structure, compile types. And there are annotations, or sometimes called decorators, that are already being thought about as well. And all of these things really will help the DI and lazy code loading story, so that you can load the code lazily and the system can be assembled. Because by providing declarative annotations about your code base, really allows the system to be really easier to understand. Just like we have discovered that we can easier understand a system that's declarative in the form of HTML, the same thing is true for declarative in the form of how the application comes together.
So just to summarize what we talked about today, and remember, all of this is speculative. We don't know how this will end up being. But what the things that we are sure about is that we want to focus on the latest browsers, and we want to break Angular into smaller pieces so that you can help us evolve these pieces in a faster pace and adjust them to whatever you need for your application.
We also want to break it up into lots of small libraries, because we think that that's going to spur innovation, and it's going to allow you guys to take the pieces and reassemble them in different ways and come up with creative things that we didn't think about.
We would like to take advantage of the latest web standards because this will really allow us to drop some of the pieces that we currently do in Angular and push them down into the browser where they can happen faster and in a native code.
And have this concept of a synchronous DI. I think it's time for languages that are so dependent about asynchronicity, like JavaScript is, to really have a DI system that understands it as well, because once the DI system understands it, lazy code loading becomes much simpler to understand. And this goes together with ES6 modules, because they declare how code should be modularized and loaded.
zones. I think this will be a big enabler for many of the things that are not possible today, whether it's helping with polyfills or debugging and long string traces, or testing and mocking of a global state in the browser.
And finally, take advantage of the future of JavaScript, which is ES6, and then add a little bit of spice to it through contracts and annotations.
Okay. Thank you so much. Do you have any questions that we could answer right now?
Yes, over here in the front.
On the ES6 part, is there already a notion of type with the introduction of the class, or is this just something you would like to add with the contracts?
So ES6 already, the question was, the question is, does ES6 already understands the concept of a class? And the answer is yes. Class is a first-class citizen in ES6, and the syntax we've shown you, where it says class, foo, and so on, that's a first-class citizen in ES6, which I think that particular portion of the standard has been stabilized, and the standard bodies are committed to it, so it's unlikely to change. And it is something that's available already inside a tracer, so you can take advantage of that as well.
Another question?
We must have explained everything very well.
Okay, there's something in the back.
Yes? What will be the default development language for Angular? As I said earlier, I really wanted to make sure that JavaScript is a first-class citizen. So we're going to build Angular in ES6 plus all these extra annotations. We're going to build these annotations and types into Tracer. And our Angular language, the Angular itself is going to be built with this. But we're going to generate out is a JavaScript code, and JavaScript code that's minified. And we're going to make sure that any of these annotations, as I pointed out, can be easily done inside of JavaScript. So you as a developer should have an absolute choice, and you should not be penalized in any way, whether you want to use ECMAScript 5, or whether you want to use ECMAScript 6, or you want to go all the way up and do ECMAScript 6 with these type annotations that we have. It should be totally your choice, and it should be absolutely equivalent.
What about Dart?
What about Dart? Dart is a completely different language, and it requires a different VM, and there's a different Dart to JS story. And for that, there's a separate Angular Dart project that takes advantage of that. There's too many differences in libraries and VMs, etc.
The semantics of the language are different enough that it makes sense to have two different code bases for the two projects. Can you use contracts for some form of static checking? I think so. The way we plan to implement this feature would actually make it possible to do static checking, but in addition to that, also have additional runtime checks, which will be more extensive than what you can do with the static.
But I also want to add to it that TypeScript is kind of pioneering this particular work, and my guess is that there's a relatively high probability that it's going to get included in the future versions of ECMAScript standards. And we want to make sure that when we design these contracts, they're going to be done in such a way that it will not affect the ability for the compiler to check them statically at compile time. So the compiler could do some checking statically, but then it can generate all these assertion statements, and so it can get a lot better about dynamic assertion. So for example, today in TypeScript, you can have a function that takes a string, and if what you have is type any, the compiler will happily pass it to you because any could be a string. But that's not the same thing as actually having an assertion inside of your code that when it runs, it actually says, no, you are indeed a string. And so you can catch all these errors early.
Question in the front?
Yeah, what you said is that for the next version of Angular, for a later version, you're going to base it on ES6, right?
Mm-hmm.
But still compatible with ES5 for developers, but as a minified version. So if I would be developing still on ES5, how would I go to in a debug mode to still be able to...
That's an excellent question.
What is the development story for...
So, repeat the questions. The question is, if you're going to write it on ES6 and then we're going to spit out a minified version to you, how are you going to debug your code? That's an excellent question. And I'm glad you brought this up because, as I said, I really want to make sure that you in no way are forced to do this. And so when we generate code out of a tracer compiler, not only do we want to add all these features to it, but the output of it would actually be human-readable code with closure-type annotations. The idea would be is that if you happen to already have a library or your application using closures and using the closure annotation syntax, which is just extra comments that you place inside of your code, then you can basically say, oh, I'm going to write a new class. I have a choice. I can write this new class in ES6 using Tracor. That will spit out something that looks human readable and has these extra annotations that the closure compiler understands, and then that gets fed through and minified. So it's not the tracer compiler itself that's going to produce minification. It's that the tracer compiler will produce a human readable closure annotated code, which is what we're going to give to you as a non-minified version, and we're going to further minify that. And when I mean human readable, I mean we're planning on preserving spaces and comments and everything that's in the original source code and just translating it over as close as possible to
Additionally, also source maps.
Yes, you should be able to see all that stuff because the syntax, so there's a couple of things in ES6. There's the syntax, which we're really interested in, but there's also different things like var and let and so on. It's unlikely that we will use those features because let creates pretty insane looking code, and so we don't want to create this insane looking code so that you don't have to look at it. So we're going to stick to essentially ES5 syntax within method bodies, but we will take advantage of classes on the higher level.
I would also like to mention that source maps can help you go all the way back to the original ES6 code. And keep in mind that all of this is just for transitional period. ES6 will be standard soon, and all the browsers will have it implemented natively. And then all of this will go out of the window, and you can just use native debugging tools.
Yes. Yeah, source maps are part of it. Tracer already generates source maps.
Other questions?
What does soon mean in the context of ES6? And are you planning to maintain both the Angular code base and the Dart code base at the same time? Or do you want to delegate it to the Dart?
Okay. So the question is, what does soon mean in terms of standards? That's a very good question.
Not the same thing that means to you.
I think what is ES6 is slated for 2016?
I actually don't know. But so there have been some recent changes to the way ES6 is being evolved, and what has been decided is that instead of going this all or nothing way of standardizing ECMAScript, they're going to release it feature by feature. So we'll start seeing different features of the ES6 standard implemented in browsers and being widely accepted as the stable thing and part of ES6. And this will help us get to the ES6 much faster than otherwise we would.
But also, part of ES6 is already implemented in V8. So there's a flag you can use in Node.js to enable it, and also a flag to use inside of Chrome browsers to enable it as well. So you can actually do it today, and then have a transpiler story for the rest of the browsers. There was a second part, about the Dart. And the question about the Dart was whether we're going to maintain two separate copies, and the answer is yes. The Dart semantics and the JavaScript semantics are sufficiently different that there is no good way of bridging them. So we are essentially just going to have two projects that are going to be same in spirit. We're going to keep them in sync in that way, but there's sufficient differences in there in the libraries, etc., that we cannot have them API compatible.
Right. To deal with this, we've grown the teams from 3 developers to, I think it's 12 right now, if I'm counting correctly. Because internally in Google, we use both JavaScript and Dart, so we need to maintain both of them. So that's the story.
Those libraries will be in sync someday, yes.
Angular Dart and AngularJS, will they be in sync? As I said, they will be in sync in the spirit. They're not going to be in sync on like API level, or like, we're not going to fix the same bug here and there because it's a different code base.
One thing we observed with doing the Angular Dart project was that going from like AngularJS to Angular Dart allowed us to try new things and learn from Angular Dart. and we are now bringing all of these learnings back to JavaScript. And I think this kind of leapfrogging where the JavaScript, the Dart version goes ahead and tries something new, and then we bring it back and add some more stuff to JavaScript, and then we can bring that to Dart, is a very good way of iterating through the framework. There's a few more questions.
Where can one find out more about the CS6 contracts that you've shown?
Right on this
It's
slide.
right
Take
here.
the barcode and
So we should have mentioned that if you guys are interested in helping us with any of this stuff, if you find any of these ideas crazy enough and interesting enough that you would like to get involved, please let us know. You can just catch us on Twitter or Google+, and we can talk about this further.
You know, I actually have to tell you a story. A few weeks ago, there was an HTML5 conference, maybe a month ago or so, and I gave this talk, and there was a person from the audience, his name is Tommy. He came to me and says, you know, I'm very interested in this. Can I help? And I said, sure, absolutely. And he's actually the person who's right now working on adding these annotations and type system into Tracer, and he's actually made pretty good progress to the point where we can actually, the annotations are actually already working.
Yeah.
So you can make a change. And we do love you.
I love you too. This effort and what TypeScript is doing is related. Is that fair to say? It's not
It's not the same thing, because what we are trying to do is have runtime type system, or we call it contracts just to make it
Repeat the question. Are they is the TypeScript and the contracts related, was the question. Should I?
Go.
Okay. And so they're not related per se. We do talk. Actually, I did have meetings with TypeScript people. TypeScript is interested in static verification, which means compile time verification. I'm interested in a runtime verification. And I want to do it in such a way where the two of them are complementary rather than competing. So ideal looking forward in the future, we would like to keep the syntax, the same exact syntax what TypeScript has, so that TypeScript can verify things structurally at runtime, compile time. But in addition to that, we can actually have things happening at runtime as well. And these things are not exclusive. These things are together.
The runtime time system, the contracts are more expressive. You can check for things that you cannot do at the static verification time.
That'd be very cool. What you showed with the syntax is different, right?
Most of the code was pseudocode, so don't worry about that. Like, as we said, don't take anything that you saw
It's
too
the spirit
seriously.
that you have to follow.
I think it'd be very cool if the syntax was aligned.
It's my goal. It's definitely my goal.
Any other questions? Go ahead.
Suppose I have to start a new project today. Why should I prefer AngularJS over AngularJS?
So if you're starting a project today, whether you should prefer AngularJS versus AngularDart, we would like to make that your choice, not our choice. We have Angular. We'd like to support as many languages as possible. We support CoffeeScript, JavaScript, ES6 is coming. We want to basically make it your choice. You choose the language you want, and you should be able to choose the framework you want. Those two things should be independent.
In our experience, even at Google, we see that people prefer different languages depending on their past development experience and the things that they like. So we don't want to be forcing you to, you have to do this or that. There are people who like JavaScript and like the dynamic nature of it. There are people who really like Dart because of the types and all of the structural stuff and all these features that Dart brings. So depending on what is it that you prefer, you should make the choice. Is Angular Dart production ready?
Well, is Angular Dart production? It's a very good question. We've just released 0.9 beta. What that means is that we actually internally at Google have apps running on Angular Dart that we're using production, but not something you can see externally, but something that our salespeople use internally. So in that sense, it's production ready because products are running. But in the sense that, is the API stable? Probably not. There's features that we know of that's still missing, and we have to catch up with them, etc. So things will be evolving until we get to 1.0.
No more questions?
Thank you guys for
Thank you,
coming.
guys.